Hello. For this screencast, I guess this is week number 9 screencast. Um, I had a question and a comment on this particular document that I'm showing you, which is a reading mapping surface charge distribution to explain current. The idea of how electric fields must be developed and set up in order to cause current to flow through a wire. Um, And so we came up and developed this notion, and through the lab too as well, of how the electric field in this picture here, for example, the electric field would go from more positive to less positive charge locations. So I understand that electric field would be directed from B to C, and then C to D across the resistor, and then D back to A, which is the negative terminal of the battery. But according to this diagram, this arrow is showing that the direction of the electric field would be from A to B, if I'm understanding that correctly. But actually, it should be directed from B, the more positive terminal, to A, the negative or less positive terminal. And so that's one, I guess, mistake, I believe, or at least a confusing point about how this diagram is showing us how the electric fields are directed. And so for the worksheet, or the lab rather, lab 2, when we were doing the lab in step 6, we had to draw the direction of the electric fields. And let me get back to this, actually. Lab 2, so that we can sort of have a common talking point. And so here, right here, the direction of the electric field as tested by the potential differences would be directed from B to C, and then C to D, and then D to A. But then the electric field goes from the more positive terminal B to the less positive terminal A. Because when you go ahead and measure the potential difference with your probe, you should get a positive potential difference when you go ahead and put the black probe on A and the red probe on B, suggesting that B is at a higher potential, which makes sense, and the electric fields go from high potential to low potential. And so anyway, that's a little bit of it's a difference from the reading diagram. And one in which I think I have the correct understanding. And, I guess it confused me initially that the electric field would be directed in a clockwise loop from B, C to D to A, but then all of a sudden the electric field would go from B to A. So that, I guess, in a sort of rudimentary thinking, it suggests that, I guess, positive charge would pile up at A, but then also the electric field being directed from B to A suggests, I guess, initially I was thinking, okay, yeah, so, and my kids had this discussion with me, and they were thinking that, there's more positive charge that piles up from the electric field going from B to A. But that's not the way that works, because the charge doesn't necessarily flow through the battery. But what's happening is that chemical reactions, redox reactions, are sort of doing work to pump, in essence, the positive charge where it's collecting. As it moves through the circuit, you pump that uphill to the location, the positive terminal. And so I guess that's a way to describe it, and a way that I kind of had my students think about it. That work is done to move the positive charge back uphill. And, that seems to be a reasonable way of thinking about it and describing it. And then I guess, even though the electric field is from the positive to negative terminal, there is no charge flow through the battery because of the high resistance. I'm thinking of the battery, and so the charge isn't able to flow, and that's where we have to have kind of the surrogate chemical ions, or the ions, to flow and transfer the charge, the positive charge, from A to B, so that we get continually renewed quantity of positive charge that can flow. And I understand that it's not really positive charge flowing, but according to Ben Franklin's convention, we kind of use that to describe the model, and use positive charge as the moving object. And so that was enlightening, and I thought it was valuable in the lab. Okay, so in here, and then another point I wanted to bring up is the idea of whether or not you will see there is much of a voltage drop through the wires themselves. And there must be a voltage drop through the wires themselves so that an electric field is set up, since electric field is equal to the potential difference divided by displacement. There must be a voltage drop through the wires in order to cause the electric field, which drives the current. And the question here, though, is in the bare wires, when we were able to go ahead and measure potential difference along the section of wire, I saw on my multimeter that there was no potential drop, basically no measurable potential drop according to my readout on the multimeter, between B and C and D, and then E and F and A, which suggests that there's no electric fields set up in the bare wires. Now, my thinking was, there must be some potential drop. I'm just not measuring it. I may need to measure in millivolts or something. But I didn't do that, and I should have. But anyway, then it led me over to, I continued on with the lab, working in step 4. And now, when you have not step 4, step 7. And now when you go ahead and work through, the potential drops, potential difference at across various locations, through insulated wires connected to light bulbs, I did see, for example, a voltage drop between B and C, between D and E, between F and A. And so my question was whether or not that voltage drop was real. And so I guess since the bare wire didn't have any voltage drop, then why would you see voltage drop from B to C, say? Well, I guess my thinking is that the alligator clips are copper wire, potentially. I'm assuming copper wire in the wire itself, but then the alligator clips, I'm thinking, are made of a different metal. A different metal that has a different amount of resistance, which then could cause a voltage drop to exist. And so I guess that's a question I had, is whether or not we're seeing the voltage drop across the metal in the ends, the clips themselves, or is it representative of the voltage drop through the wire itself? So that's a little confusing to me, and I guess I looked into it to some extent, but I am still kind of floundering with that that difference in thinking. And so I'll stop here and finish up with another screencast.